So here's how to do variation of parameters. We start with two linearly independent solutions of some second-order linear ODE, not necessarily constant coefficient. The first step is to divide all the way through by P2 the coefficient of the y double prime term, so that we get a new equation where y double prime has a coefficient of 1. So that looks like this here. The next thing is to solve the system. Well, actually, the next thing is to make the guess that yp looks like u1 y1 plus u2 y2. And to find that, we need to solve the system where we've got u1 prime y1 plus u2 prime y2 equals 0, and u1 prime y1 prime plus u2 prime u2 prime y2 prime equals f. And this is why it's important to divide through by capital P2 in order to make sure you have the right thing coming in here for your f. And so we solve this system for u1 prime and u2 prime, and then we integrate to find u1 and u2, and then we have our coefficients, and we can find yp by just assembling things back together with this linear combination here. Okay, so that's one way to think about how the method works. There's also a way to think about it in terms of matrices. So what we have here is if we take this matrix y1, y2, y1 prime, y2 prime, let's call that x, then what we have is x times u is our particular solution, and then some junk we don't care about. Where xu prime is equal to some matrix, some vector b, and in particular it's this one 0f. Okay, so then that tells us what we need to do. So we need to solve xu prime equals b. How do we do that? Well, we multiply both sides by x inverse. So u prime is going to be x inverse b. And we know what x inverse looks like for a 2 by 2 matrix. It looks like 1 over the determinant, and if you take the determinant of that matrix, you get the Wronskian. So it's 1 over the Wronskian times, and then you have, let's see, so we swap the two entries on the diagonal, and then we negate the two off-diagonal entries. And that's what we're going to be multiplying 0f by. Okay. And so then, let's see, so that's going to give us 1 over w times minus y2f, and 1 over w times y1f. Okay, and then that's u prime. So u is going to be the integral of this business. And then we're going to take x times u, and we will get our particular solution and then some junk we don't care about. And so if we look at x times u, this is going to be, so we've got y1, y2, y1 prime, y2 prime. And then I've got that u that we solved for. And so across the top we have y1 times the integral y2 f over w, and that comes with a minus sign. And then we have y2, and then integral of y1 f over w. And then I'm not going to bother to work out what that other one is because I don't care. So that tells us that yp is minus y1 times the integral y2 f over w plus y2 times the integral y1 f over w. So this gives us an explicit formula. So different people like to use variation of parameters different ways. You're free to use either the algorithm that I presented first, or this matrix formulation, or just basically plugging into the red boxed formula. Either one will work.